Here we want to find this double integral here. And so again, to evaluate this double integral, we can try to evaluate it directly. First, evaluate the inside integral, which is this integral. So this integral is with respect to y. And therefore the x squared is considered a constant. So antiderivative of a constant will be the constant times y. So it's x squared times y. Antiderivative of y squared would be y to the third divided by 3. And then we need to evaluate from this to this. And so first, in the place of y, we have the square root of 9 minus x squared. In the place of y, we have the square root of 9 minus x squared. That's for the upper limit of integration. And then the lower limit of integration is negative square root of 9 minus x squared. So we have negative square root of 9 minus x squared. Square root and then negative square root of 9 minus x squared. And now to do the double integral, we replace this inside integral here with this expression. This expression here. And now we will integrate with respect to x using numerical integration. We get 127.23 approximately. And now let's evaluate this double integral using polar coordinate system. So recall that the relationship between the rectangular system and the polar coordinate system is r squared is equal to x squared plus y squared, where x is equal to r times cosine theta, y is equal to r times sine theta. And this is how the double integrals are related. This double integral is in the rectangular system, and this double integral is in the polar coordinate system. And so to go from the rectangular system to the polar coordinate system, we looked at the boundaries here. The inside integral is with respect to y, and so the lower limit integration, this is y equal to negative square root of 9 minus x squared. This is y equal to the square root of 9 minus x squared. The outside integral is with respect to x, so this is x equal to negative 3, x equal to 3. And so what we can do is look at the graph, this graph, and this graph. And so we can see what the polar region looks like. This top half here, this is the equation y equal to the square root of 9 minus x squared. The bottom half of this circle here is y equal to negative square root of 9 minus x squared. Once again, this is y equal to the square root of 9 minus x squared. This is y equal to negative square root of 9 minus x squared. And so that's the y. And then we can see that the x ranges from negative 3 to 3. And so in the polar system, the radius of this circle here will be from 0 to 3. And if we go from here to here, that's theta from 0 to 2 pi. Because it's the entire circle. So it'd be 0 to 2 pi. So starting right here, starting at the polar axis, and then if we go all the way around, that's 0 to 2 pi. And so for theta, we have 0 to 2 pi. For r, we have 0 to 3. The function here is x squared plus y squared, but x squared plus y squared is r squared. And so that's what we replaced this with. F of r theta will be r squared. So this is f of x, y. F of x, y is x squared plus y squared. F of r theta will be r squared. And then we have r here, so it'll be r squared times r dr d theta. So once again, the range for r will be this circle right here. Is a circle of the radius 3. So that's why we go from 0 to 3. And then there's the entire circle, so we go from 0 to 2 pi. And now this becomes r to the third. R squared times r is r to the third. The antiderivative would be r to the fourth, dividing by 4. And then evaluate from 0 to 3. Replacing r with 3, we get 81 over 4. Replacing r with 0, we get 0. So we get 81 over 4. And now integrate with respect to theta. Then we get 81 over 4 times theta. And then evaluate from 0 to 2 pi. And so we get 81 times 2 pi dividing by 4. And then minus 0. We get 81 pi over 4. Which is about 127.23. So this is the exact answer. And so for the double integral, sometimes it's easier to evaluate this double integral using the polar coordinate system instead of evaluating it directly.